In this lesson, we're going to learn how to identify the chiral centers in a molecule. When a molecule has a chiral center, it tells us that the molecule has a non-superimposable mirror image, and this will become more important when we look at specific types of isomers. For now, we're going to learn to identify these chiral carbons by looking at the groups attached to that carbon. The way we're going to identify chiral carbons is that they have 4 unique groups around the atom. So this is a simple molecule. There is one carbon atom in the middle, and we're going to look at the 4 groups that are attached to it. We see we have a hydrogen, a fluorine, a bromine, and a chlorine. Because we have 4 different groups or 4 unique groups, we say that this is a chiral carbon. To relate what we've seen with the tetrahedral geometry, which results from having 4 electron groups around an atom, and how we often draw this on paper, we want to make some connections between our 3D drawing and our drawing with what we call our dashes and wedges. So notice that we have hydrogen and fluorine, and these are in the plane of the screen. So we draw those with regular lines representing the bonds. When we look at bromine and chlorine, we see that bromine in the drawing on the right is shown with a wedge, and that indicates that it is coming out of the screen towards us. And chlorine, which has the dashed bond, means it's going away from you, so it's going behind the screen. One thing that you need to be careful about when you're looking at the unique groups attached to a carbon atom, you need to remember that you have to look beyond the next atom. So when we look at the carbon in the middle of this molecule, we see we have a hydrogen group and a bromine group. When we look at the other groups attached to that carbon, we see that they both start with a carbon atom. However, we cannot stop with just that one atom, and we have to look at the entire group. So here on the right, we have a CH3 group, and on the left, we have a CH2CH3 group. The molecule on the right is just a different representation of the structure. So when we look at these two groups, we see we have CH3 and CH2CH3, and these are different groups. Therefore, this is a chiral carbon in the middle because it has 4 groups attached: hydrogen, bromine, CH3, and CH2CH3. When we move on to larger molecules, we will need to look at multiple carbon atoms to determine if they are chiral. If there is at least one chiral carbon in a molecule, then we say that we have a chiral compound. There can be multiple chiral carbons, and it's still a chiral compound. If there are no chiral carbons in a molecule, we would call that achiral, which means it is not a chiral compound. Let's look at the example given here. First, I'm going to number my carbon atoms to make it easier to follow along. Then I'm going to draw in the hydrogen atoms on each of those. What I need to look for now is determine, are there any carbon atoms with 4 unique groups attached? When I look at carbon 1, I see that it has 3 hydrogen groups. Therefore, it cannot be chiral because it cannot have 4 unique groups because 3 of its groups are hydrogen. Likewise, for carbon 2, it has 2 hydrogen groups. So once I have 2 groups that are the same, I don't need to look at it any further because it cannot be chiral. Carbon 4 also has 3 hydrogen groups, so it cannot be chiral. The only carbon I need to look at is carbon 3, and I look for the groups attached to that carbon. My first group is fluorine. The second group is bromine. My next group is a 2-carbon, so CH2CH3 group, and the fourth group is CH3. So I see that carbon 3 has 4 unique groups attached to it. Carbon 3 is chiral, So we have a chiral compound. Does this molecule contain any chiral carbons? The first thing we want to do is draw in our hydrogen atoms because that will help us eliminate possibilities for chiral carbons. I see that most of the carbons have multiple hydrogen atoms attached, therefore none of those carbons can be considered chiral, because even if there are two hydrogens, I now have two groups that are the same, which eliminates the possibility of it being chiral. Now I have one carbon left right in the middle of the molecule that I can look at to see if it's chiral. My first group is chlorine, my next group is CH3, then I have a CH2CH3 group and a CH2CH3 group. Because these groups are the same on the left and the right side, this is an achiral molecule because none of the carbons are chiral. Does this molecule contain any chiral carbons? First, we're going to add in our hydrogen atoms. And we know we can eliminate any carbon which has two or more hydrogens attached as a possible chiral carbon. We can also eliminate any carbons involved in a double bond, because if we look at the second carbon in the chain, we'll see that it only has three groups attached. And so if it only has three groups total, it can't possibly have four unique groups. So any carbons involved in a double or triple bond cannot be chiral. When we look at the central carbon, which is the only carbon that has the possibility of being chiral, we have a chlorine group, a CH3 group, a CH-CH2 group, and a CH2-CH3 group. And this molecule is considered chiral because it has four different groups. The group on the left has two carbons and the group on the right has two carbons, but the presence of the double bond changes something about it, so the group on the left and the right are different. Therefore, the carbon in the middle is considered a chiral carbon and the molecule is a chiral compound.